Okay, when you're solving rational equations, it's not that they're too difficult, they're just kind of annoying. So here are the steps. Make sure all the denominators are the same. And then once the denominators are the same, you can kind of ignore them. But all the denominators need to be the same. Once the denominators are the same, just solve for the numerators. So let's get started on this first one. So notice what we have to do on this first function. If we multiply top and bottom this by 5, we'll have 5n. And if we multiply here top and bottom by n, which is what I did here, then they're all going to have the same denominator. We can ignore it and start solving for the numerator. 5 times 6 is 30, and we're going to subtract all of this. But when we do that, 30 subtract 2 is 28, but I think that I went ahead and simplified first. Yep, I simplified first. Notice on the left side, they all share the same denominator, so we can write it as one fraction. 5 times 6 is 30. Subtract all of this. And over on the right side, n times 1 is just n. Again, we're going to ignore the denominator, simplify the numerators, and what we have is 30 subtract 2 is 28, and 30 subtract n, we just are left with subtract n. There's that invisible 1 right there. Well, I want to get the n's to the same side, so I'm going to add a 1 in. I'm going to add an n. And we're left with 28 is equal to 2n. And then when we divide both sides by 2, boom, n is equal to 14. And then with your calculator, you would just have to double check that when you plug 14, let me erase this stuff. When you plug 14 into this original function, this side will equal 1/5, and you just check that with your denominator. Okay, I mean with your calculator. All right, I'm going to cover up this side so we're not distracted by it. Well, notice this one's pretty easy. This is the only one that doesn't share the same factor. I mean the same denominator. So I'm going to put that invisible 1 underneath, and then we're going to multiply top and bottom by 2m. And when we do that, notice in the numerator, these two things can be added and they can be put over the same denominator. And it's 1 plus all of this stuff. And that's equal, well, 2m divided by 2m is 1. So we haven't changed anything, except for we can now ignore the denominator and focus on the numerator. So 1 plus negative 2 is negative 1. And then that leaves us with m subtract 1 is equal to 2m. Well, I'm just going to subtract an m from both sides, and boom, negative 1 is equal to m. And then again, you'd have to put negative 1 up there and all of that to make sure that when you plug negative 1 right here, and right here, and plug all of that into your calculator, that when you hit enter, it's going to equal positive 1. All right. On square root functions, they can be a little bit tricky. These simple ones are not too bad. We want to get n by itself, but what's the undoing of taking the square root? Squaring. And when we do that, the square root undoes, the squaring undoes the square root. So I think I have that written down over here. Yeah. Those two things cancel, would leave an n divided by 2. Well, 1 squared is 1, so when we simplify, and then the undoing of dividing 2 is multiplying 2. Those cancel, and what we have left is 2 is equal to n. And then you just go ahead and check it. Whoops. Plug 2 back into here. Well, 2 divided by 2 is 1. The square root of 1 is 1, so 1 equals 1. Check. Now when we move to this right side equation over here, we need to get the x's to one side, but this x is underneath the radical, so we're going to have to square both sides. I probably did that. And when we square the left side, that undoes that, and that leaves us with 2 subtract x is equal to x squared. And then kind of an alarm should go off in your brain. Oh, it's an x squared. It means it's a quadratic. We need to get all of this stuff over to the other side. And remember, if it's x squared, the next thing will be an x to the first. So the opposite of negative x, we're going to add x to both sides. The opposite of positive 2, we're going to subtract 2. Boom. And then we're going to have a quadratic. And then once we have a quadratic, that quadratic is going to factor. Factors of negative 2, that add up to positive 1 right there. So positive 2, negative 1, these two numbers multiply to be negative 2, but they add to be positive 1. And then, boom, x is equal. The opposite of 2 is negative 2. The opposite of negative 1 is 1. And then we have to check both answers. If we plug negative 2 here, we plug negative 2, well, subtract a negative is like adding a positive, but the positive square root of 4 is 2. But over here, it's negative 2. So the negative 2, even though it works algebraically, it doesn't work when you plug it in, and that is an extraneous solution. Meaning it works when you do the algebra, but it doesn't actually work when you plug it back in. So 1 is our only answer. All right. And I'm going to quickly show you how to do this, but I'm not going to walk you through it all the way. Whoops. I put the parentheses around the wrong thing. You're going to have to put a parentheses around all of this. Doggone it, I did it again. Let's see if I can look at the equal sign now. So we're going to square this and square this. And we're going to square both sides. And when we square this side, this is the first term and the second term. It becomes this Pascal's triangle situation. A perfect square binomial. So you can break it down this way. We've been working on Pascal's triangle. It simplifies to this, simplified a little bit more, because 9 and 6 is 15, and then negative b, and all of this stuff. We're going to simplify that a little bit more, meaning we're going to get this by itself. So we're going to subtract 15, and we're going to add a b to both sides. Well, 2b plus b is 3b. Negative 3 subtract 15 is negative 18. And once we get it to this, we have to repeat the process. Yep. So whoops. You repeat that process again. And we're going to get it to this quadratic that does not factor. So that's when you're going to use the quadratic equation. And then we're going to have our two x values. We have x is equal to negative 8 plus 2 root 13. And x is equal to negative 8 subtract 2 root 13. All right. All right, I'm going to end this one right here.